Hello, welcome back to Math 332 Linear Algebra, and this is again sections 1.2 Gaussian Elimination. This is the second part of the presentations. All right, so let's get started. All right, let's first look at the objective for this video. So after this video, you should know what are the pivots and what are the free variables, and how do you determine the consistency of a linear system by looking at the RREF matrix, and more importantly, how do you write down the solutions of your linear system if your linear system is consistent. All right, so in the previous video, we learned how to write this particular linear system into its augmented matrix, and we actually learned how to actually perform the Gaussian eliminations. But in this video, we are not going to look at how to do the Gaussian eliminations. We are just going to look at the RREF matrix at the end of the Gaussian eliminations, and learn how to write down the solutions. So let me remind you one more time that these equations here, this first row here are telling you that your x1 minus x2 plus 0, x3 minus 2 over 7 x4 equals to 0. This is what this augmented matrix represents. So every row gives you an equation that looks like this. So that's the reason why. So from the previous video, like this row gives you this. Okay, this row right here gives you this. Okay, this row right here gives you this, and this row right here gives you this. So every row of this matrix represents the equation. So this is the equations that it represents. Okay, so this is something that's very important to kind of remind you before we look at how we actually read off the solutions by looking at this REF matrix. So again, now this is the REF matrix. You can write down x1, x2, x3, x4 on top of it to remind you of what those variables represent. So once you have that, once you have the REF matrix, so let's recall what are the pivots. So pivot is the first non-zero entry if you read from left to right for this particular row. So you read from left to right. So the first non-zero entry, this is the pivot. And you can also see that everything above and below that pivot is 0. So the second pivot is right here, and you can see everything above and below that pivot is 0. And you can see that there's no pivot on the third row, and there's no pivot on the fourth row. So there's only 2 pivots for this equation, for this REF matrix. So these are the pivots. And so x1 and x3 are what I call the pivot variable. So let's write down the solutions like this: x1, x2, x3, x4. And I just, as I mentioned, x1, okay, so remember this is like an equal sign. So if you move this across, you will change the sign. So x1 is x2, and then plus 2 over 7x4. Remember, this is in equations, right? And equations with the equality right here. So when you are moving something across the equality, you will have to change the sign. That's the reason why we have that. So this is x1, our pivot variable. So second pivot variable is our x3. So again, what is x3? x3 is 3 over 7x4. That is our x3. Okay. So the one that get left behind, this is going to be our free variable. This is the things that we can freely assign its value. And so this is our free variable. This is our free variable. So this is a system of equations that has infinitely many solutions. The system, we do have a solution for this linear system, and in fact there are infinitely many of them because of this free variable. Because x4 and x2 can take any numbers that you can think of. You can assign all type of number for your x2 and x4. So your x1 will have to adjust accordingly. Your x3 will have to adjust accordingly. But your x4 and x2 can be any numbers. So because of that, this is a system that is consistent, and these are the free variable. So the way to write down the solution is actually pretty straightforward. So you identify your pivots variable, write your pivot variable, make your pivot variable like this, write everything related to pivot variable like this, and everything that's get left behind are your free variable. So another thing we can do, this is writing it in a matrix form, which will come in very handy. So once we have that, we can also regroup all the x2 and all the x4 like this, and write our solutions in this particular vector form. This is what we call a vector form. And I'm kind of assuming that you know how to multiply matrices or scalar multiplier matrices and stuff like that. If not, this will make a lot more sense after section 1.3. But this is basically writing our solution x1, x2, x3, x4 as a column vectors. This is what we call it as a column vectors. And this is a type of matrix. This is a matrix of size 4 by 1. Okay, this is a type of matrix called column vectors. And we basically copy everything down right here. And we are writing all the x2 stuff together and all the x4 stuff together. And you can see all this x4 here, kind of like the common factor. We can factor it out. And the x2 here is kind of like a common factor. We can factor it out. You can multiply this thing in and multiply this thing in and add them component by component, and you will get this particular column vector. So you can verify that, and then once you verify that, you will know exactly what this is about. So again, what I'm saying is that you can multiply x4 to every component of this vectors of this matrix, multiply x2 to every component, and you add up every component like this. You will see that this is what you get. So this is another way of writing our solutions. We'll keep writing our solution like that. This is going to come in very handy for our course. So this is some things that you need to know how to write as well. So this is a solutions in a vector form. So this is another way of writing it. So as you can see, as I said, by varying the x2 and x4, you can generate infinitely many solutions. So if you write a solution like this, you can see if I set my x2 and x4 to be 0, I can do that because these are the free variable. So I can set my x2 and x4 to be 0. These are my free variable. So I will have my solutions. This is one possible solutions. I can set my x2 to be 1, my x4 to be 0. So I will get this as my solutions. I can set my x2 to be 0, and I can set my x4 to be 7. This is something that I will get by doing that, and so on and so forth. I can generate infinitely many solutions, as you can see, by playing with the x2 and x4. And this is the concept of free variable that we talked about in the previous video. So these are something that a variable you can freely assign its value. This is very critical. You must know how to start from a REF matrix and write down the solutions and write as a matrix form and be able to see that these are the free variable. Okay, so these are the free variable that generates infinitely many solutions. So this is an exercise. I would like you to pause this video and write down your solutions. So maybe I can say that this is a REF matrix that corresponds to a linear system that has this variable x1, x2, x3, x4, x5. So this one right here is basically telling you that you have x1 minus 6x2 equals to 2. All right. So these equations right here are telling you that you have x3 plus 4x5 equals to 7. And this equation right here are telling you that your x4 plus 5x5 is equals to 8. So how do you write down your solution x1, x2, x3, x4, and x5? So all this thing is, this is a bread and butter of linear algebra. This is like very, very important. This is super critical to be able to write down a solution for an REF matrix. So I would want you to give it a try. So I want you to pause the video right now and write down your solutions for your x1, x2, x3, x4, x5. Okay? All right, let's do that. Okay, assuming that you have done it. So as I said, this is a x1, x2, x3, x4, x5. So let's look at the pivot variable. So this is our pivot variable. We have one pivot right here. So our pivot variable is x1. This is a second pivot variable, which is x3. So our pivot variable x1, x3. That third row, this is our pivot variable x4. And there's no pivot variable right here. So our pivot variable is x1, okay, x3, and x4. So your x2 here will be our free variable. x5 here will be our free variable. So this is x2 equal to x2, x5 equals to x5. So that's what free variable means. So x1, what is x1? So look at the x1. You will see that x1 is 6. Okay, move this across. 6x2, okay? And then you have a 2 right here, so that's a plus 2. Okay, what is your x3? So your x3 is, okay, move this across, so you have a minus 4x5. Okay, this is x5, and then you have original as 7. And x4, what is the x4? So x4 is minus 5x5 plus 8. So that's how you get your x1, x2, x3, x4, and x5. So again, key thing is identify a pivot variable. This is a pivot variable. This is a pivot variable. This is a pivot variable. Write down what your pivot variables are. And the rest of the stuff that get left behind, in this case, our x2 and our x5, these are considered as a free variable. Meaning that you can assign any type of values for the x2 and x5. And then your x1, x3, and x4, your x1, x3, and x4 will have to adjust accordingly, according to your x2 and x5, which are free. Okay, so again, you can rewrite this into this particular vector form, and you can see the solutions for the systems is infinitely many, because you can freely assign the values for x2 and x5. So you can freely assign the value for x2 and x5, and you can generate infinitely many solutions from there. So as I said, these are the free variable. And then once you assign a number to this, assign a number to this, your pivot variable will have to adjust accordingly. Okay, so that's the concept of pivot and free variable. And this is critical. This is your bread and butter, and you must know how to do it. Otherwise, you will have a lot of trouble in this course. This is kind of like taking a calculus class and doesn't know how to take the derivative. This is kind of like taking a linear algebra class and learn how to take the derivative. This is critical. We are going to do that a lot. And I want you to really know that this is really the bread and butter of your linear algebra. This is like the critical skills. If you don't have this skill, you will be in trouble. Okay, now let's look at another example. So this is an augmented matrix, corresponds to a linear systems with variable, let's say x1, x2, x3, x4. So let me remind you again, this equation is right here, tells you that you have 1x1 plus 2x2 plus 0x3 plus 0x4 equals to 3. Okay, so sometimes we just lazy and just write this. Okay, so every row gives you equations. And the interesting part is that if this is a RREF matrix, these rows are telling you that you have 0x1 plus 0x2 plus 0x3 plus 0x4 equal to 2. And you will see there's just no way in the universe that you can find x1, x2, x3, x4 that will satisfy these equations. Meaning that there's no way you can find numbers, these 4 numbers, so that this is true. So immediately, if you have a RREF matrix that looks like this. So again, if you have RREF matrix that looks like this, so you have a whole bunch of 0 on the left-hand side of this vertical line and the non-zero right here, then immediately you would know that the system is inconsistent. There's no solutions. Okay? So again, same thing as before, all the linear systems, there's only 3 possibilities. You have either unique solutions, no solutions, or infinitely many solutions. So you have seen infinitely many solutions will looks like this, and this is how no solution will looks like. And unique solution, we have seen it from the previous video when we do the row operations. We have one particular x, one particular y, and one particular z, and we cannot have any other thing else. So those are our unique solutions. Okay, so this is an exercise that I want you to give it a try. So right here, you can take this is your x, y, and z. And the question is, what should be the B1, B2, and B3? What kind of relationship should this B1 and B2 and B3 satisfy so that the system will be consistent? So you will realize that doing the row operations on unknown like this is a little bit tricky. But we can do it. And in order to answer these kind of questions, we don't really have to turn this into a REF matrix. We can just reduce it all the way to a point that we can kind of see something, then maybe we can just stop and you will be able to see what are the solutions, what kind of relationship B1, B2, and B3 has to satisfy in order to make sure that the system actually has a solution. So I want you to take a few minutes and work on it, and then we'll look at the solutions, okay? All right. So if you do this row operations, so let's look at the equation here. So suppose you want to kill off this number and kill off this number, and if possible, kill off this number. So by doing all that, you should get a matrix that kind of looks like this. So again, I want you to give it a try. So if you have trouble, we will talk about it during our virtual meeting in class. But if you manage to get to this point right here by doing a few simple row operations, you will see that this system can only be consistent if this part here is 0. Right? So if you have 0, x1 plus 0, x2 plus 0, x3 equal to 0, this is fine. This is okay. This is fine. But if you have a non-zero number like this, then this is not okay. Right? So in order to make sure the system is consistent, we'll have to make sure that this B3, B1, and B2 have to satisfy this relationship. So only the B1, B2, and B3 that satisfy these conditions will make the system consistent. Otherwise, the system will not be consistent. All right, so we will do a lot of this kind of computation and exercise in class, in the exam, in the quizzes, and stuff like that. So I will want you to absolutely sure that you know how to write down your solutions if you are given an REF matrix. So if you already have an REF matrix, how do you write down your solutions? So that's critical. How do you write down your solutions? So the key thing is remember how to identify your pivot and remember how you identify your free variables. And also remember how to identify your REF matrix is inconsistent. Your REF matrix is inconsistent if you run into trouble like this. Okay? All right. That's it for this video. All right. Very well. That concludes our discussion on section 1.2, Gaussian elimination part 2. I will see you in the next video.